The oceanography of Cubagua. The wind, the river, and the deep basin that made the Pearl Coast possible. In our previous chapter, we followed the history of pearls across thousands of years, from the fisheries of the Persian Gulf and the courts of ancient Rome to the great trade networks that connected civilizations across the Old World. Yet one question remained unanswered. Why did a small, barren island in the southern Caribbean become one of the richest pearl-producing regions in history? That island was Cubagua. Located off the northeastern coast of present-day Venezuela, between the larger islands of Margarita and Coche, Cubagua appears unremarkable at first glance. It has no rivers, no forests, and very little fresh water. Even today, it is a windswept landscape of limestone, thorn scrub, and desert-like terrain. Yet beneath the waters surrounding the island lay an extraordinary natural treasure. So abundant were its oyster beds that early Spanish explorers would come to know the region simply as the Island of Pearls. The answer was not found on the island itself. It was found in the sea. There is a moment each year, usually sometime in December, when the Caribbean begins to change along the northeastern coast of South America. The trade winds strengthen, the sky clears, the air becomes drier, and beneath the surface, an invisible transformation begins. For months, the sea has been influenced by the great rivers of the South American continent. The water is warmer, less salty, and often clouded by sediment carried from far inland. Then the winds arrive. As they sweep across the Caribbean from the northeast, they push surface water away from the Venezuelan coast. And when that surface water moves offshore, something remarkable happens. Cold water begins to rise from the depths. It carries with it nutrients that have accumulated hundreds of meters below the surface. Nitrates, phosphates, minerals, and the biological wealth of generations of marine life. Within days, the sea awakens. Microscopic phytoplankton multiply in extraordinary numbers. The water changes color. Fish gather. Dolphins arrive. Whales pass through. Seabirds circle overhead. And across the shallow banks surrounding Cubagua, Coche, and Margarita, millions of pearl oysters begin to feed. This annual transformation is one of the great natural events of the Caribbean, and it helps explain why a seemingly worthless island became one of the most productive pearl fisheries in history. To understand why, we must follow four powerful forces that converged in this corner of the Caribbean. The first was the Orinoco River. The second was the northeast trade winds. The third was the Cariaco Basin. And the fourth was the network of shallow carbonate banks surrounding the Pearl Islands. Together, they created one of the most productive marine environments in the Atlantic world. The story begins far inland. The Orinoco River rises in southern Venezuela and drains one of the largest watersheds in South America. By the time it reaches the Atlantic Ocean, it has become one of the great rivers of the world. Every year it carries enormous quantities of fresh water into the sea. But it carries much more than water. It transports minerals, nutrients, organic matter, and the accumulated biological wealth of an entire continent. During the rainy season, the river expands dramatically. Its freshwater plume spreads far beyond the delta, extending hundreds of kilometers into the Caribbean. Modern satellite imagery reveals just how vast this plume can become. For the Pearl Coast, its effects were profound. The nutrients carried by the river helped fuel marine productivity throughout the region. At the same time, the fresh water reduced salinity and increased turbidity. The sea became warmer, murkier, less transparent. For pearl divers, these conditions presented challenges. For the ecosystem, however, they represented preparation. The river was loading the system with nutrients that would soon be transformed into life. That transformation occurred when the winds arrived. Between December and April, the northeast trade winds intensify with remarkable consistency along the Venezuelan coast. These winds trigger a process known as upwelling. As surface water is pushed offshore, colder water rises from below to replace it. The source of this water is one of the most extraordinary marine features in the Caribbean. The Cariaco Basin. Located just offshore from the Pearl Island, the basin is a deep underwater depression reaching depths of more than 1,400 meters. For centuries, organic material has accumulated within its depths. As that material decomposes, nutrients build up in extraordinary concentrations. When upwelling occurs, those nutrients are carried toward the surface. The results are immediate. Sea temperatures drop. Water clarity improves. Phytoplankton blooms spread across the region. The sea turns green with life. Modern scientific studies have confirmed that this seasonal upwelling ranks among the most productive marine events in the tropical Atlantic. The same process that attracts fish, dolphins, whales, and seabirds also feeds the organism that matters most to our story. Pinctada imbricata, the Atlantic pearl oyster. This species is perfectly adapted to the seasonal rhythm of the Pearl Coast. During the productive months, when phytoplankton is abundant, oysters feed aggressively. Growth accelerates, reproduction increases, and inside certain oysters, layer after layer of nacre is deposited. Over time, pearls begin to form. Each pearl becomes a record of its environment, a biological archive built season by season. A quiet witness to the rhythm of river, wind, and sea. Yet even abundant food would not have been enough. The oysters required another essential ingredient. They needed a place to live. The shallow banks surrounding Cubagua, Coche, Margarita, and the Araya Peninsula provided exactly that. These underwater landscapes consisted of rocky ledges, shell accumulations, coral fragments, and carbonate platforms, ideal surfaces upon which oyster larvae could settle and grow. The banks were shallow. Many lay within depths that could be reached by breath-hold divers. No equipment was required, only skill, knowledge, and endurance. The result was extraordinary. A vast network of oyster beds flourished across the region, fed by nutrients from the Orinoco, energized by upwelling from the Cariaco Basin, sustained by the trade winds, anchored to the shallow carbonate banks of the southeastern Caribbean. No other known pearl fishery combined so many favorable conditions at once. The Pearl Coast was not the product of a single environmental factor. It was the product of an entire system working in harmony. The Columbus pearls are products of that system. Each one formed within an oyster nourished by phytoplankton blooms born from river discharge, seasonal winds, and nutrient-rich water rising from the depths. They are more than gemstones. They are records of a remarkable marine environment, a place so productive, so unusually favorable, that it would soon attract merchants, explorers, conquerors, and fortune-seekers from across the Atlantic world. The story of Cubagua begins with wind, water, and life. A river carrying the minerals of an entire continent. Trade winds rising across the Atlantic. And a deep basin whose hidden nutrients transformed a barren island into one of the richest marine environments in the world. But another question remains. Who first recognized the extraordinary wealth hidden beneath these waters? How did indigenous communities harvest the oysters that thrived along the Pearl Coast? And what happened when Europeans arrived and discovered what the sea had already been producing for centuries? In our next chapter, we leave the world of currents and oceanography behind and turn to the people themselves, exploring the remarkable history of the Pearl Coast. To explore additional research, images and historical resources, visit the columbuspearls.com. Until next time, thank you for listening.